Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
Go above and beyond.
they become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Dr. Cheng Fang. She's the VP of Research at Annovis, Annovis. And we're going to talk about Alzheimer's and Parkinson's and other neurodegenerative conditions. So Cheng, thanks for coming.
Hi, Richard. Thanks for having me here.
If you would, tell me first a bit about your background. How did you come to Annovis and what have you worked on for the past X number of years?
Yeah, absolutely. I came to the US for a PhD program. Believe it or not, my focus at that time was cancer, but in the PhD program, they rotate you to different labs so you can find the one that's most interesting to you. The first one that I went to actually is neuroblastoma. So I went in for cancer, but I got really interested in neuroscience. So I actually got a PhD in neuroscience, focusing on learning anxiety and depression, the molecular mechanism behind it. So then I continued on with my focus in neuroscience. So I went to OHSU, worked with Dr. Gary Banker on neurodegenerative diseases, started with Huntington's disease, and then later on worked on multiple sclerosis. Then I went to Boston University as assistant professor, working on prion disease and Alzheimer's disease. Then I decided I wanted to learn more about, the drug development. How can I leverage my background research and I go into drug development? So I joined Clarivate as a scientific consultant, working with top 50 pharmaceutical companies. So this is actually quite interesting. Get me fast drug R&D really fast is to learn how do those companies approach drug development? How do they find new targets, new biomarkers, and what indication they would go into? So when Annovis Bio had this job opening, I find it just perfect match. Leveraging both my training, my passion for neuroscience, and also my experience.
Excellent. So what are some of the projects you're working on right now at Annovis?
Yeah, we have really cool projects. We are working on wrapping up our phase 2A clinical trials in Parkinson's disease and in Alzheimer's disease. We're actively preparing the documents, working with FDA to discuss our next steps. We just got the approval for green light for going to Parkinson's disease for phase 3. And we're still waiting to have the end of phase 2 conversation with FDA for our Alzheimer's disease.
Yeah, I've spoken to a number of folks about Alzheimer's. I do want to ask you about it, but Parkinson's, very few. Would you mind telling me what happens with people that have Parkinson's and how it progresses? And then I want to ask you about the drug that you're working on.
Yeah, absolutely. Parkinson's disease actually is the second biggest neurodegenerative diseases in the United States. So Alzheimer's disease impacts about 6 million people here in the US, and Parkinson's is 1 million. So it's not a trivial number, but definitely it seems like a smaller population compared with Alzheimer's disease. So Parkinson's disease was patients would have those palsy, involuntary shaking, and it affects their mobilities. So at first is unilateral, impact their movement, and then progress into bilaterally. Late-stage Parkinson's patients also developed into dementia. It's called Parkinson's disease dementia.
Yeah, that's terrible. What are the neurological underpinnings of Parkinson's? Has anyone figured out why it happens?
That's a billion-dollar question. So for all of these neurodegenerative diseases, there is known cause, except that the biggest contributing factor is age. So your chance of getting both Alzheimer's and Parkinson's dramatically increase after you pass a certain age. So for Parkinson's disease, what we know is those patients' brains would have those clumps. They're called Lewy bodies, which mostly is one protein, alpha-synuclein protein. It would aggregate together to form those clumps, Lewy bodies. So it's also, that's mostly pharmaceutical companies and treatment has been focusing on.
Yeah, it seems like in Alzheimer's, the tau tangles and the plaques are clues, but they're also like red herrings. So is it the same with Parkinson's? These Lewy body clumps, they may be present, but no one really knows if they're a result of Parkinson's or if they're the cause of Parkinson's. Is it similar like that?
Yeah, absolutely. I think our way of thinking is exactly like just because you see it mostly in the pathology after a patient passed away. So that means that happened. And it could be at first a self-defense mechanism from your brain, and then later on itself becoming devastating. So we believe, also I think this is in agreeing with what I have observed over the years through studying different neurodegenerative diseases, is those different devastating neurodegenerative diseases, even though they are very different, phenotypes wise, right? Patient manifestation. But if you look at their brain, look at the molecular level, there's so much similarities. For example, in Parkinson's disease, everybody is talking about this alpha-synuclein because it forms Lewy body. But tau, which is, a culprit for Alzheimer's disease, is also there and plays an important role. And TDP-43, which is a protein that's associated, with Lou Gehrig's disease, is also there. So I think these days there are more and more research started to shining lights on all these proteins that have been there all along and contributing to the pathology, but has been overlooked.
So what is the drug that's in the pipeline for Parkinson's, and what's the mechanism of action?
Right. So that just ties back to our belief in first, multiple neurotoxic proteins are existing in all the neurodegenerative diseases. No matter, in Alzheimer's disease, sure, the main culprit is, tau and amyloids, but we know that, you can beautifully remove those amyloids, but patients don't show those huge improvement, right? So because what we believe is all those neurotoxic proteins, they have similar pathways. So if you just remove one of the bad guys, all the other ones are still there and damaging your brain. So our approach, our drug, the USA name is bontanetap, previously known as Posivin. So it actually inhibits the translation of all these neurotoxic proteins. That's why it can work in both Alzheimer's disease and Parkinson's disease. We've been showing efficacy in both patient groups. And I actually believe it can work on more of the other neurodegenerative diseases. Of course, that needs more research.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership. from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show.
I know with Alzheimer's, again, it seems to, people have been able to remove the amyloid plaques, but it doesn't seem to affect the Alzheimer's positively. Is there any indication that the same thing will happen with Parkinson's, or what are the hypotheses on how to treat Parkinson's that you're working?
Yeah, I think you are right. That's why we don't believe in removing one single neurotoxic protein, right? So, for example, in Alzheimer's disease, amyloid hypothesis is one prominent hypothesis. And people tried many different ways for decades to remove this amyloid plaques. Right now, for better or for worse, Biogen has done a great job in removing those plaques. But the results shown that there is minimal efficacy. So I think that would be the same thing for just removing tau in Alzheimer's disease, or just removing the alpha-synuclein in Parkinson's disease. That's the difference between our drug and all the others, is buntanetap actually at the same time inhibits all the neurotoxic proteins. So in that way, it can stop all these toxic aggregating proteins from damaging your brain. So in animal research, we already shown that if you give them in 7 different animal models from Alzheimer's disease, Parkinson's disease, stroke, and the traumatic brain injury, and acute glaucoma. So if you give them the buntanetap, it can work very early on, because those proteins first works, in your body at a very subtle level, not just to form those aggregates. Those are later on. So they have already toxic effects to form your axonal transport, which is the information flow in your neurons, and to impact your synapses integrity, which is how your memories are formed. So in those animal models, we've shown that we can rescue those, and therefore we can rescue the neuronal function and the animal's behavior. And we have demonstrated that in our recent phase 2A clinical study that actually holds true in humans as well.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
So Parkinson, or the Lewy body is just in the brain, or, because of the tremors and everything, is that, again, a brain center action that gets compromised, or is it more diffuse and in Parkinson's various areas of the body?
Yeah, that's a great question. It's mostly in the brain, because Parkinson's disease they're known for losing the dopaminergic neurons. That's why the main drugs out there is L-DOPA. So basically, it's a similar approach as in Alzheimer's disease. We're trying to produce a neurotransmitter, which is a chemical for neurons to communicate with each other. So in Parkinson's disease, because of losing dopaminergic neurons, you're losing dopamine. So we are providing the drug L-DOPA is a precursor for dopamine. So that's why the patients would get some improvement. But you have a very good point, is actually alpha-synuclein is everywhere. It's also one of earlier symptoms for those Parkinson's patients. One of them is a GI malfunction. So you actually buntanetap also can reduce the alpha-synuclein in the gut system and help them we've shown that in animal models to improve the GI functions.
Are you guys looking at all at diet or are there certain comorbidities that accompany Parkinson's and or Alzheimer's that might be revealing or interesting?
Yeah, we're not looking at it, but definitely, I think, as passionate as I am about our drug, but I think, because all these are just really complicated diseases, right? So there are multiple drugs that, if have different mechanism of action, could have synergistic effects, right? For example, diabetes, we know that, if you have diabetes, you have 30% more likely to get Parkinson's disease, and so is Alzheimer's disease. right? Just by increasing your glucose level. So yeah, we are not looking into it, but definitely a very interesting and fascinating areas.
So I don't know, are there any promising threads that you're looking at that you don't really have enough information on yet that you can discuss?
Interesting threads in our trials that we're not looking at?
In addition to the trials that you're running, are there other hypotheses that are earlier on that you haven't gotten to this point yet with FDA, but that you're considering, that you're able to talk about?
Yeah, absolutely. We did a project funded by DoD to looking at how buntanetap was helping the TBI because, it's traumatic brain injury. We know it's actually quite prevalent. Now it's almost like Alzheimer's. Once people recognize this is a disease, you start to understand, it's the prevalence of it. So to our very amazement and surprise, actually, it's not surprise, actually, because even though the damage of the brain, the mechanism is different, right? From Alzheimer's and from Parkinson's, you might have those culprit proteins overexpression and cause your neurons damage. But for traumatic brain injury is at first you got physical force trauma and to cause those neurons to have those response. One of the neuronal, the pathology response or stress response is to produce lots of the neuroinflammatory factors and oxidative stress. And also they would produce high ion level. So high ion level would actually trigger lots of the neurotoxic proteins to overexpress. So all these eventually would come to a very similar molecular mechanism. I think that's how our drug actually works in many of those different disease areas. So that's one area I think is really interesting and definitely worth pursuing. And the other area is for Huntington's disease. So recently we did a collaboration with UCSD, Dr. Bill Mobley's lab, to understand, how many of the proteins in your cell actually are, whose translation is regulated by our drug. So we did two approaches. One is targeted, right? We think these few proteins, because of the structurally similarity, they should be affected. So the other way, we did it unbiased. We actually use proteomics to look at all your proteins in the cell to look at what proteins are regulated by our drug. Both come to the same conclusion that a few culprits of the neurotoxic aggregating proteins are regulated by our drug. One of them is Huntington proteins, the culprit for Huntington disease. So that's another very exciting development and something interesting for us to pursue down the road.
I don't know. It just seems like these conditions are really intractable. But in just terms of basic statistics, what's the prevalence of Alzheimer's and Parkinson's nowadays? How many per thousand or per million? And is it increasing? Do you have any background numbers?
Yeah, for Alzheimer's, it's 6 million right now in the United States. I believe it's the number 5th leading cause of death if you are 65 and above. For Parkinson's, it's running up. It's the second most biggest neurodegenerative disease. It's 1 million right now in the United States. So with the population aging, so these would be becoming more of a problem.
Yeah, that's crazy. Well, very good. Cheng, what's the best way for people to find out more about Annovis and also about your work? Where can they go?
Yeah, they can come to our website. It's www.annovisbio.com. We have all our scientific information over there. And also we're adding a new page for the patients to find our upcoming trial information.
Okay, good. Any place else or just, Annovis website and that's...
Yeah, once we have the trial date started, we're working with Michael J. Fox Foundations and a few other patient advocacy groups to put our trial information on their websites as well. So same with Alzheimer's disease.
Very good. Well, Cheng, thank you so much for coming on the podcast. I really appreciate it and your work. Thank you.
Thank you for having me here.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.